Let W be a random variable giving the number of tails minus the number of heads in 3 tosses of a coin. List the elements of the sample space S for the 3 tosses of the coin, and to each sample point assign a value W. Now, when you toss a coin 3 times, you could have heads on all the 3. You could have head, and a tail, but this is 2 heads and a tail, but this can occur in 3 different ways. You could have the tail at the end, you could have the tail in the middle, or you could have tail in the beginning. Similarly, you could have 1 head and 2 tails, and this can also occur in 3 ways. The head could be in the beginning, it could be in the middle, it could be at the end, or you could have 3 tails. So this is the correct sample space. So we already know it's choice D, and W is the number of tails minus the number of heads. So in this point, there are 0 tails minus 3 heads. So this would be -3. Similarly, here we have 1 tail minus 2 heads, so that would be -1. This would also be -1, 1 tail and 2 heads. 1 tail and 2 heads. Now here we have 2 tails and 1 head, so that 2 minus 1, which is 1. Again, 1, 1. Here we have 3 tails and 0 heads, so 3 minus 0, which would be 3. Determine the value of C so that each of the following functions can serve as a probability distribution. Now, in a probability distribution, if it's a discrete random variable, it means that the values can be counted. For example, 0, 1, 2, 3, here's 0, 1, 2, counted versus not countable. So if it's countable, then it's discrete. And in this case, the sum of all the probabilities in a discrete space is 1. So here we should have f of 0 in part A. It's f of 0 plus f of 1 plus f of 2 plus f of 3. That's equal to 1. So we're doing part A now. So f of 0 would be C times 0 squared plus 5. Plus f of 1 would be C times 1 squared plus 5, that is 6. F of 2 would be 2 squared plus 5, that'd be 9. And f of 3 will be 3 squared plus 5. 3 squared is 9. 9 plus 5 is 14. And this all adds up to 23, 29, 34C. So this gives C is equal to 1 over 34. In part B, we have combinations given. So in this case, X only goes from 0, 1, and 2. So in part B, we will have f of 0 plus f of 1 plus f of 2. That's equal to 1. So f of 0 is C 4 combination 0, 2 combination 2 minus 0, plus f of 1 would be C times 4 combination 1, 2 combination 2 minus 1, which is 1. And then f of 2 will be C times 4 combination 2 and 2 combination 2 minus 2. 2 minus 2 is 0. And all that needs to add up to 1. Now, 4 combination 0 is 1. 2 combination 2 is also 1. So this is just C. Here, 4 combination 1 is 4. 2 combination 1 is 2. 4 combination 2 is 6. 2 combination 0 is 1. So 8 plus 6, 14. So you have 15C. So C will be 1 by 15 in this case.